Hello, everybody. I hope you are all doing well and welcome to this session of Enlightening Math. Today, we will be going over absolute value at a pre-algebra level. Let's dive right in. So to begin, what is absolute value? The absolute value of a number tells us how far that number is from zero on a number line without considering the direction. Because distance is always non-negative, the absolute value of a number can never be negative. So here we have a little diagram. Absolute value A equals A if A greater than zero, negative A if A less than zero. So examples, the absolute value of 5 is 5, yeah, which makes sense. Now the absolute value of negative 5 is also 5, because once again, it is a distance between that point to zero, and distance can never be negative. So if you visualize it and you take the number negative 5 on a number line, count how many spaces it takes to get to zero. It would take 5 spaces or 5 dots. That's basically what absolute value is. So once again, absolute value is 0, 0, because the distance from 0 to 0 is still 0. So as it says, 5 and negative 5 are both 5 units away from 0 on the number line. So absolute value as a distance. The absolute value of a difference shows a distance between 2 points on a number line. For example, A minus B equals distance between A and B, or absolute value A minus B equals distance between A and B. So an example of this would be absolute value 4 minus negative 3 is equal to absolute value 4 plus 3, because two negatives cancel out, which is equal to absolute value 7, which is 7. So what this tells us is the distance between point 4 and point negative 3 on a number line. Those 2 points are 7 spaces away. Example number 2 here. If we take a point negative 2 minus point negative 6, we get absolute value negative 8, and that's just 8. So this tells us that if we're looking at point negative 2 on a number line and then point negative 6 on a number line, point or positive 6 on a number line, because the equation says it's negative minus b. So this would be minus negative 6, which is positive 6. So the distance between negative 2 and positive 6 on a number line is 8 spaces. So let's go through some step-by-step evaluation. We can go through some practice. So simplify the inside of the bars first is what we always do. And then use the absolute value. So example 1 here, point negative 4 plus 9. So that becomes the absolute value of 5, which is just 5, which means the distance between point negative 4 and point negative 9 is 5 units. And we say the distance between negative 4 and negative 9 because once again, in the equation, this number, this symbol here should be a negative, but since it's a positive, we know that it's negative 9. Another one over here, distance between 0.7 and 0.11 on a number line. So absolute value negative 4 or 4. So 4 units apart. Now, we have some multiplication here. So absolute value 2 times negative 3 is equal to absolute value negative 6, which is equal to 6. So what this one tells us is that the absolute value next up, we have absolute value 4 minus 5, which is just absolute value negative 1, which is just 1. And then absolute value negative 8 plus absolute value 3, which is just 8 plus 3, which is 11. So on a graph, when we look at it, or on a number line in this case, absolute value 3 means 3 moves 3 spaces to the right from 0. For absolute value 4 moves 4, means 4, the point 4 is 4 units to the right from 0 once again. Example distance between, so if we take 0.2 and then point negative 4 on a number line, we can, what this is telling us is that we can count 6 spaces in between these 2 points on the number line when we look at it graphically. So we have absolute value equations now. To solve absolute value x equals k, where k greater than or equal to 0. So x either equals k or x equals negative k, which is k is just another variable we use. So this is basically telling us that these absolute value equations have two solutions most of the time. So for the first one, absolute value x equals 7, which tells us x either equals 7 or negative 7. Absolute value x equals 0. This case has one solution because zeros can only be 0 points away from 0. And then absolute value negative 5. So this one has no solution because distance can once again never be negative. So now we have equations with expressions, absolute value expressions. So if the bars contain an expression, for example, x minus a equals b, absolute value x minus a equals b, there's two solutions. The first of which being x minus a is equal to b, the second of which x minus a equals to negative b. Then we just simplify and solve. So an example would be x minus 3 equals 5. So x minus 3 can either equal 5 or x minus 3 can either equal negative 5, which means x can either equal 8 or negative 2. So now we have absolute value with inequalities. So as it says here, absolute value x less than k would mean negative k is less than x, which is less than k. Or absolute value x greater than k, which means x less than negative k or x greater than k. So one example of this would be absolute value x less than 4, which means negative 4 is less than x and x is less than 4. We can move past the other examples. You guys could look through them if you want on your own. So real life application of this would be temperature change. We can look at how the temperature changes throughout the days. This would most often be used in Celsius and not Fahrenheit, as Fahrenheit does not get to the negatives. Elevation. So if we look at underwater sea levels compared to above ground, we can use absolute value equations to compare the distance. And then banking, when withdrawing and inputting money into your bank account, it can also be used. So here's some common errors. The first of which, thinking absolute value makes numbers positive by changing signs, but it doesn't really do that. It just flips, it finds a distance, which it does end up changing the sign. Forgetting to solve both the positive and negative cases in an equation. Once again, it has two solutions unless it either equals a negative or 0. Assuming absolute value x equals negative a has a solution, it never does if a is negative. And then misordering steps, you must always follow the order of steps. So here's a quick summary table. You guys can go ahead and screenshot that. And then for those of you who want, we have a challenge problem here. I'll stay on this for a quick second. You guys can take a picture. And then key takeaways from this lesson. Absolute value represents distance, not direction. Always simplify the bars before evaluating. Equations with the absolute value often have two solutions. Absolute value inequalities describe ranges of values on a number line. And always check your solutions to make sure they are valid. That's all for today, guys, and thank you for your time.